Hello everyone, I'm AMMAJI DUPPADA, and today we are going to see method 10 of solving differential equations. The T is available in first order and first degree. So far we have seen all the differential equations of first order and first degree only. But this method is generally available in non-exact differential equation form. This non-exact differential equation form, again same, we have to convert into exact differential equation form by multiplying with an integrating factor. Here integrating factor is different, but firstly the question or the problem which is available in this form, the function f1 of variables x comma y into y dx plus function f2 of variables x comma y into x dy is equal to 0. Actually it is looking like this whole thing, if you treat as m function of x comma y, this whole thing if you treat as n, it is looking like m dx plus n dy is equal to 0. So now this equation is non-exact. Of course it is non-exact. So the given equation is non-exact. Non-exact condition, you know that. So non-exact condition is it should satisfy like dou m over dou y should not be equal to dou n over dou x. So okay, the first condition is satisfied, let us say. So it is non-exact. Remember, firstly, we have seen non-exact equations in different forms. Method 8, 9, we have seen in different forms, but here form is different. So the given equation is non-exact and available in this form. In that case, you have to convert processes you have to convert your non-exact equation into exact equation. You have to convert exact differential equation. So how? By multiplying with an integrating factor. Multiply with the integration factor. It means the whole equation should be multiplied by an integration factor called 1 over mx minus ny. You know what is m? Total function of x comma y into y. You know n, f2 of x comma y into x. The whole thing is n. So if you calculate this integrating factor and if you multiply with this integrating factor the whole equation or the whole given problem, your equation will become exact differential equation. If once the equation become exact, you know the procedure how to solve it. We have seen in previous methods of various methods that are available in the previous videos. So you know direct solution. There is a direct equation. You can find the direct solution from there. So this is the procedure if the form is like method 10. So now we will see an example, but before that, remember we have seen in the beginning, if it is non-exact, different methods we have seen, which is called first one non-exact, that can be solved by using inspection method. Non-exact can be solved by using inspection method. Number 2, non-exact but homogeneous. Non-exact but homogeneous. Now the third thing now we are doing in this line, that is called method 10. In the method 10, non-exact but available in this form. Which form? f1 of some function into y dx plus f2 into x dy is equal to 0. This is the third case in non-exact forms like. So now we are seeing this method by taking a direct problem. So now I'm going to explain an example. Let me take an example. This 1 plus xy into y dx plus 1 minus xy into x dy is equal to 0. Now, see, it is looking like this is function of x comma y, right? This is function of x comma y. This is also function of x comma y. You can treat f1 of function of x comma y into y dx plus f2 of function of x comma y into x dy is equal to 0. Now it is like method 10 form only. Now I told you one more thing. You have to treat this whole thing as m dx plus this whole thing you have to treat as n. Remember, here only the confusion comes, like when you are taking it as an m, please include this y also. When you are taking n, please include this x also. This x and y are included in m and n. Otherwise, your problem will be you will be landed with the wrong answer. So now you know m comma n. If you calculate generally, now you know m comma n. Now I will write separately. M is y plus xy squared. N value is x minus x squared y. So this is what m and n values are. Now if you calculate dou m over dou y, dou n over dou x, definitely it is non-exact only. It means, so I'm not calculating. Please you calculate yourself, because so many problems we have done so far in the beginning, how to calculate and all. Dou m over dou y definitely not equal to dou n over dou x. So my equation is non-exact. My equation is non-exact. So if it is non-exact, okay, in this case, what I do is I calculate separately here. Dou m over dou y, dou m over dou y. The first term, this I am doing. First term is 1, second term is x constant 2y. It means 1 plus 2xy you will get. What is dou n over dou x? 1 minus y constant 2x. 1 minus 2xy you are getting. It means dou m by dou y is not equal to dou n by dou x. So it is non-exact. So okay, my condition is satisfied. Now what is my next step is, like I have to convert into non-exact. To convert into non-exact, you have to calculate integration factor. To convert into non-exact into exact, calculate integrating factor. What is integrating factor? 1 over mx minus ny. In the case of homogeneous, non-exact and homogeneous, their integration factor is 1 over mx plus ny. Here 1 over mx minus ny. So now 1 over mx means m into this, calculate into multiply x, xy mx plus x square y square minus ny xy minus x square y squared. So 1 over xy will be cancelled, minus minus plus, so 2x square y square you will get. 1 over 2x squared y squared. This is what we call integrating factor. It means if you multiply with this integrating factor the whole given equation, your equation will become exact. Your equation will become exact. Now let me go for another page. So let me go for another page. 1 over 2x square y square is the integrating factor I got. So I write once again the given equation. Given equation is, let me take the problem once again. 1 plus xy into y dx plus 1 minus xy into x dy is equal to 0. Now what is the integrating factor we got? 1 over 2x square y squared. You multiply with this, the whole equation, you multiply with this integration factor. What you will get? So if you see y plus xy square over 2x square y square into dx plus this x I am multiplying with this, okay, x minus x square y over 2x square y square into dy is equal to 0. Now y over this value, how much you will get? Y over 2x square y square, 1 over 2x square y. 1 y will be cancelled. Second term is xy square by this. It means 1 over 2 will be there. Bottom one x is there in the denominator. Y square term is cancelled. So into dx plus this term x over 2x square y square means 1 over 2xy square minus x square will be cancelled. One y term will be there. 1 over 2y dy is equal to 0. Now, this equation, I'm telling that it is exact, but you have to check once again. If you treat this one as m1, if you treat this one as n1, you calculate dou m1 by dou y, you calculate dou n1 over dou x. They should be equal because it is exact. I'm telling because I converted already the given non-exact equation to exact equation. Now I am saying that this is exact, but you have to verify, right? So please verify by calculating dou m1 over dou y and dou n over dou x. With respect to y, if you do 1 over 2x square is constant, differentiation of 1 by y, it means minus 1 by y square. Minus 1 over y square. It means minus 1 by 2x square y square. Okay, second term. Okay, second term anyhow with respect to y, x is constant. So second term is 0. So I'm not writing. So dou m1 over dou y is this value. Dou n1 over dou x. With respect to x, if you do 1 over 2y square is constant. First in the beginning, first term. 1 over x. 1 over x means minus 1 over x square. It means second term is 0 because y terms only. So minus 1 over 2x square y square. So I have verified that my converted equation is exact. The converted equation is exact. So now if the equation is exact, so what we have to do? We have to apply a direct method. We have to apply a direct method. What is the direct method? So the direct method is, so if it is an exact, what is the direct method? Integration of m1 of some function of xy, m1 dx, y should be treated as constant. Integration of n1 dy is equal to constant. Here, remember, n1 is free from which terms? X terms. So this is the case like. So now, what is m1? What is n1? Integration of m1. M1 value is, we have seen already. So here I am taking, just I am going back to the another this page. This is the value called m1. This value, this is called n1. So 1 over 2x square y over 1 over 2x. So m1 value 1 over 2x square y plus 1 over 2x into dx. Remember, y should be constant while operating this operator. While operating this operator on this, remember y should be treated as constant. Plus integration of n1 into dy. N1 value, it should be free from x terms. So if you see n1 value have 1 over 2xy square, 1 over 2y. So see, I told you one thing like you keep x is equal to 0. But remember, if you keep in the denominator x is equal to 0, something by 0 become infinity. So don't, it is like blunt, I said, don't put x is equal to 0. Remove just wherever x is there, the term you remove, that's it. So don't put x is equal to 0. Okay, if you put x is equal to 0 here, this term become infinity. Infinity means nowhere you can solve this problem. So remove this term because it is having x term. So only minus 1 over 2y term is there in n1. So take that term only. Minus 1 over 2y. Minus 1 over 2y into mdx plus ndy is equal to constant. That's it. Now solve this one. So if you treat y as constant in the first integration, 1 over 2y is constant. So integration of 1 over x square. Integration of 1 over x square means x to the power minus 2 dx. What is the second term? 1 by 2, 1 over x log x. What is the third term? Minus 1 by 2, 1 over y means log y is equal to constant. So what is this term? X square, x power minus 2, x to the power n formula like x to the power n plus 1 by n plus 1. So x to the power minus 1 by minus 1. So 1 over 2y, x to the power minus 1 by minus 1. So it means minus, I can bring this side, plus 1 by 2 if you take common, log x minus log y, log a minus log b, log a by b, I can write log x over y is equal to some constant. So finally, my 1 by 2, 1 over x I can write x power minus 1. So 1 over 2xy minus 1 over 2xy plus 1 over 2 log x by y is equal to some constant. So this still I can modify the solution. 1 by 2 I can take common, I can bring that side. So log x over y minus 1 over xy is equal to 2c. So still you can 2c you can make it c dash, like log x over y minus 1 over xy is equal to c dash. 2c become, you can write c dash, because a real constant multiplied by a arbitrary constant, finally you will get an arbitrary constant only. So I am making 2c as c dash, an arbitrary constant. So this is the final solution of the given problem. This is final solution which is available in small x and small y only, because your problem is given in small x and small y only. So once again, let me recap everything from the beginning. Let me, yeah, hope it's looking good. So now we are seeing method 3. Actually, in the non-exact itself, this is the third method. Actually, in the non-exact, first one inspection method we have done. It means if the given equation is non-exact, first you have to check whether you can do by using inspection method or not, whether it is non-exact, homogeneous or not. If the two cases are not satisfied, then you come to third case. If the given function is non-exact and available in this form, which form? This form, like f1 into x comma function of f1 function into y dx, f2 function into x dy is equal to 0. If that is the case, you have to convert non-exact equation to exact equation by multiply with an integrating factor called 1 over mx minus ny. That thing I have solved with this, I explained with this example. So in this, I calculated 1 over mx minus ny integrating factor. I multiplied the whole equation with this integrating factor, and finally I converted into exact. Once the equation become exact, I know what is the direct solution that I can apply. We have the formula. That formula I have applied. Finally, we got a solution. As simple as that, this method is. And remember, from now onwards, actually in the video, mostly I try to share this photo also, like this pic in PNG format, this whole board, this whiteboard I will share with YouTube link. So you can see that one also. Thank you. Thank you all for watching this video.